Hello, I am Sharad Maharaj, and I represent the Extraction Studies Research Group of Trinidad and Tobago. One of our broad research goals is to avert the loss of our manufacturing capabilities as a country, with moral obligations to promote processes that are self-sustainable and make use of as many renewable resources as possible. In doing so, we strive to advance our local chemical engineering, agricultural, and food sectors. Market projections for plant-based extracts demonstrate a unique opportunity for Trinidad and Tobago to enter the business. If we consider Tobago, there already exists a bay tree plantation that could be used to easily establish an extraction industry. However, it was found that the plantation is unable to provide the raw material to operate a plant for an entire year. To make the operation economically viable, a strategy was proposed that involved the agricultural production of vetiver grass, from which the harvested roots can be used for extraction. The chosen extraction technique is Supercritical Fluid Extraction, abbreviated SFE, using supercritical carbon dioxide solvent, since SFE was found to be more efficient and versatile than the traditional technique of steam distillation extraction. I therefore present a process that uses recyclable supercritical CO2 as a solvent to obtain extracts from vetiver roots. Towards developing a plant extracts industry, the research objectives were to determine the optimal process conditions for commercial extraction, followed by an economic analysis to indicate whether the installation of a commercial SFE operation in Tobago might be commercially viable. To evaluate these objectives, the interactive effects of the operating parameters of pressures, temperatures, and CO2 flow rates with respect to the oil yield were ascertained using design of experiments. The ranges of the process variables were 190 to 250 bar for the CO2 pressure, 40 to 60 degrees Celsius for the CO2 temperature, and 1 to 3 milliliters per minute CO2 flow rate. A standard extraction curve was determined for each experiment by measuring the mass of collected extract every 15 minutes. Factorial design, the basis for design of experiments, resulted in an experimental program that required 8 experiments with 3 repetitive runs at the midpoint to determine reproducibility of the yield. The factors, variables, and responses for these 11 experimental runs are shown in Table 1. The resulting extraction curves from these experiments show a high rate of extraction at the beginning of each experiment, tapering off towards the end when all of the extract has been removed. This may be due to the positioning of the essential oils within the root particles. In the earlier extraction stages, the oil at the root's surface is removed, whereas the essential oil within the cells are extracted in progressive stages. This resistance lowers the mass transfer rate from within the cells compared to that from the surface. It can be seen that most of the essential oil was easily removed at the earlier stages of extraction. The extraction data was used to determine the regression model and generate contour plots to predict the variance of the response. The final equation that was obtained is shown on the slide, and deductions were based on the resulting P and F values shown in Table 2. It was determined that the CO2 flow rate and the pressure and CO2 flow rate had the most significant linear and combined effect on yield respectively. The results also showed that the model fitted well, and the optimum extraction conditions were pressure at 220 bar, temperature at 50 degrees Celsius, and CO2 flow rate at 2 milliliters per minute. The yield at the optimum condition was 4.75%, which was significantly higher than those reported in the literature. A feasibility study based on using 3 1500 liters extractors for a plant that would process bay and vetiver resulted in an IRR of 28%, making the project worthy of further development. Further work would involve a more detailed evaluation of the economic potential towards potential commercialization. The research findings are encouraging and show that we have the capability to further develop and grow our own expertise, especially during a time when global restrictions necessitate being in a self-sustainable position. I thank you for taking the time to view my presentation and will receive any questions that you can direct to me by email.